All right, so now in this video, we're going to focus on another way where we can graph these linear equations. We can make an input-output table. We could solve this for y, and we could put it in slope-intercept form, and then reverse steps. Plot the y-intercept, apply the slope to the y-intercept, draw a line. But I want to show you a third way, and it's called using intercepts. So let's think about the word intercept, okay? Let's think about what the graph of this equation looks like. It's a linear equation. It's going to be a line, okay? Don't write this part down on your notes, okay? Don't write this down. This is our y-axis. This is our x-axis. And I just want to show you something without having you write it down. If we're talking about intercepting, okay, we're talking about where our line is hitting these axes, the y-axis and the x-axis. So let's look for a pattern. That is a point 0.08. This one right here is a point 0.05. And this point right here is 0.2. Do you see a pattern here? If a line were to hit this, or a line were to hit this, or a line were to hit this, where it hits our y-axis, where it intercepts our y-axis, our x value is 0. I'm going to erase all this off now. That's why I said don't write it down. Okay, so where our line is going to hit our y-axis, our x value is going to be 0. The same thing is true, keep not writing this down, for this, where it's going to hit our x-axis, and it doesn't matter if it's here, because this is the point -7, 0. This is the point 1, 0. This is the point 8, 0. Where it hits our x-axis, our y values are all 0. So another way to graph these is plugging 0 in for x and then plugging 0 in for y, plotting those two solutions and drawing a line using intercepts. So now let's try that. Okay, just another way. We can use slope-intercept form, we can make an input-output table, we can use intercepts. So I'm going to start by plugging 0 in for x, and I'm going to go -3 times 0 plus 8y equals 24. Gone. We have 8y equals 24. Since we're solving for y and it's multiplying, I want to divide both sides by 8, and y equals 3. So a couple ways you can think of this. You can think of this as the point 0, 3, where it says y equals 3 here. You can just say, hey, y-axis, it hits 3. Either way. Now, we're going to plug in 0 for y, so you have to do it twice. Once for x, once for y. -3 times x plus 8 times 0 equals 24. -3x equals 24. Divide both sides by a -3, and we get x equals -8. So again, on our x-axis, we can go to -8, or you can think of this as the point -8, 0. Draw our line. And now we have a line that represents all the possible pairings of x and y values that will make this linear equation in two variables true. Okay, just another method. The other day we were using slope-intercept form, like changing this into slope-intercept form. You can absolutely do that with this one. You're going to get the same line. Okay, so this lesson though, we're going to practice using intercepts. They're nice to use when it's written in standard form, and you kind of can get an idea of, if you're going to be dealing with decimals. Now, we are going to be kind of dealing with decimals in this one, but I want to show you that we can still do it. Normally, if we do deal with decimals or fractions, I would just put it in slope-intercept form, but that's okay. Let's try it. Again, using intercepts, then I'm going to say 0 in for x, 0 in for y. We're still solving equations. That hasn't changed. So I'm going to go 0 minus 6y equals 15. That cancels. I'm not going to forget that that's a -6y equals 15. Divide both sides by a -6. And if you were to take a calculator and go 15 divided by -6, or change it to a mixed number, you'd get -2.5, 2.5. So this is the point 0, -2.5. So I'll just go about halfway between the 2 and 3, because that's where 2.5 would be. Now I'm going to plug it in for y. X minus 6 times 0 equals 15. Well, that's just 0, so that's x minus 0 equals 15, so x equals 15. So this is the point 15, 0. And then I will draw a line through. And again, that line, remember, the graph of a linear equation is a line. This line represents all the solutions, all the pairings. I could pick any number, any point on this graph, and it would make this a true statement. We'd get 15 equals 15. One more real quick. When I look at this, well, I guess it didn't work out too great. I was hoping I'd have one that worked out to be integers, but that's okay. We're still just practicing. So I am going to use intercepts. So I'm going to say x is 0 and y is 0 to get 2 points. Because remember, we can fill in whatever we want, okay, as long as we solve the equation for the unknown. So I'm going to go 4 times 0 plus 3y equals 21. That's gone. I'm left with 3y equals 21. Divide by 3, divide by 3. Y equals 7. So this is the point 0, 7. X value first, then y value. Put 0 in for y now. I get 4x plus 3 times 0 equals 21. That's 4x. That cancels, equals 21. Then I'm going to divide both sides by 4. And x is going to equal, I think it's 5.25. I was trying to get a calculator up. Yep, I was right, 5.25. Not that I didn't trust myself, I just want to be sure. All right, so we get 5 1/4 here, 5.25, 0. So again, this is 1/4 of the way. This would be like 5 1/4, right? So I'm going to go over just past the 5 right here. And honestly, I'm not a huge fan of using intercepts for when it works out to be decimals. But, sorry, I left it as pink line. This right now is we're just practicing. Okay, normally I'd look at this number right here and say, hey, if both these numbers go into it, I am doing intercepts. Otherwise, I'm going to use slope intercept form. But if you do it correctly, either way, you're going to get the same answer. So this lesson, this video, we're focusing on using intercepts. 0 in for x, solve, 0 in for y, and we'll get where our line, because graph of linear equation is line, where it hits our x-axis and our y-axis.